Welcome to my YouTube channel. Today we'll be discussing differentiation, but we'll focus our attention on the product rule. Product rule, as you can see on the screen, we have some basic derivation from here. I've taken my time to put it down so that we will not be asking some questions, because these are basic derivation, and it simply means whenever you have, for example, y equals sine ax, if you have to differentiate it, sine ax will give you a cos ax. If you have y equals cos ax, if you have to differentiate it, it's going to give you minus a sine ax. By implication, it means this is the differentiation of what we have here. And if you have been following our teaching, we've been able to explain the general rule of differentiation, how to differentiate, and we've been able to solve some questions. You can check our YouTube channel to get those explanations on the basics of differentiation. So in this video, we are going to be making use of this basic derivation, and as you journey through this video, you understand better how product rule operates. Now, when y equals uv and u and v are both functions of x, then dy dx equals u dv dx plus v du dx. So generally and basically, this is like a formula to solving product rule in differentiation. Someone may be asking, how are we going to know if in question we are going to be using product rule on such question? If you look at what we have here, it simply means if you have y, you'll be having two different functions, u and v, coming together. Whenever you see any question like this, it means you are going to be applying product rule. Like we have on the screen here, we have some questions. If you look at this, this is 3x squared. You can differentiate this only. This is sine 2x. You can differentiate this only. Two of them are together. The sign in between them is multiplication. That's why we call it product rule. If we have minus here or plus, that means you'll be differentiating them separately, like we have in our previous class. You can check the video. But this time around, there is no sign. That means we have multiplication here. That's why it is called product rule. If you look at the second question as well, the sign here is invisible, but it's times. That's why we'll be applying product rule. So as we journey through this video, let's solve these two questions that we're having here so that you understand better. So let's say solution number 1. Solution 1, we are going to see how we will apply the product rule, but it's an upgrade of what we have been doing from our previous video, so you can check those videos to brush up. Now, looking at what we have here and the explanation we have up here, that y equals uv, they are standing together, multiplying themselves. So if you have something of this nature, you'll be applying this formula. So let's see how we go about that. By implication, it means here now have, this is simply explaining to you that this y is this uv. So let's make u Okay, let's u equals this 3x squared. Let's take it one after the other. Let's deal with this first. And v equals sine 2x. Awesome. So if we say this 3x squared is u and this sine 2x is v, very good. So we can deal with them separately. Don't forget that if you are dealing with product rule, this is the formula we are going to use. Beautiful. Now we have dv dx. That means we can only get dv dx from here, v and x. In this formula we have du dx. That means we can only get this du dx from here, u and x here. It is as simple as that. So you have to be very careful. But we can only get our dy dx using this one. But we need to differentiate this one after the other so that we can put our value here. Okay, let's start with this. Since we have asked this u to be 3x squared, don't forget we're able to, this is u, this is v. So this u, which is 3x squared, let's differentiate it so that we can always put it here. This v, which is sine 2x, we are going to differentiate it so that we can put it here. This u, we have it already. This is it, u. Our answer is 3x squared. This v, we have it already. This is it. So let's see what we can do. Let's bring out this. Now, u equals 3x squared. So let's say our du dx now. Look here, this is it, u and x. That's how you know. So du dx now equal, as usual, our normal differentiation. Your power, you bring it back. You bring your power back. This power that you have here, which is 2, you bring it back. Then what you have here, you bring it, then you minus 1 from the power. Our general rule, don't forget. Our general rule, please don't forget. That's what we are doing. Awesome. So having done that, we say 2 times 3 here will give us 6. And 2 minus 1 here will give us 1. Anything raised to power 1 is still that, so there is no point putting what we have here. Let me see. Awesome. So we have two minus 1 will give us 1. If you put 1 here, it's still the same thing, so there is no point putting the 1. So we just say 2 times 3 here, it will give us 1. This one will give us 1, 6. Beautiful. So our du dx will give us 6x. This is just our basic. So we've been able to iron out from our formula. Now we now have our u, we have our du dx. So this is our u, this is our du dx. So let's move straight to the next one. We're able to say our v is sine 2x. Our our v is sine 2x. So our dv dx now, our dv dx will now equal, now differentiating sine 2x, let's look at our derivative. Differentiating sine ax give us a cos ax. Differentiating sine ax give us a cos ax. As you can see, by implication, if we differentiate sine 2x, it will give us 2 cos 2x. That's the meaning. If we differentiate sine 2x, it will give us what? 2 cos 2x. That's the meaning. So if we differentiate sine 2x, it's going to give us what? 2 cos 2x. Beautiful. So we've been able to get our parameters out. So let's now differentiate using our product rule formula. Beautiful. So with this now, our dy dx, what's our u? Let's impute this value we've gotten. What's our u? This is our u, 3x squared. This is our u. This is our u. So what's our dv dx? This is our dv dx, 2 cos 2x. Our dv dx is what? 2 cos 2x. That's our dv dx. So what's our v? This is our v, sine 2x. Our v is sine 2x. Our v is sine 2x that we have here. So what's our du dx? This is our du dx, 6x. Our du dx is what? 6x. So our job is almost done. So all we just need to do now is let's just open up what we have here. We have 3x squared here times 2 cos 2x. By implication, if we multiply this 2 times this 3x squared, 2 times 3 will give us 6. We now have 6x squared cos 2x. That's what we're going to have here. So let's just open up these brackets that we have here. Awesome, because you have beautiful, because we say this 3 times 2. Okay, let's bring it that way. Let's see, this one will help us. Say this 2 times 3 here will give us 6. This s squared, this is it. Then cos 2x that we have here, cos 2x. 2 times 3 will give us 6. Because we're actually multiplying all you have here. 2 times 3 will give us 6. This s squared is it. So this is cos 2x. So we now have 6s squared cos 2x. 6s squared cos 2x that we have here. Now on this side, it's just for you to multiply these two. 6x sine 2x. So it's still the same thing. Just bring your 6x here. So you have your 6x sine 2x. Awesome. So looking at these two, you can leave your answer like this, or you can say from what we have here, okay, 6x is common on both sides. So let's just bring the 6x out. Okay. So if you say you bring out 6x, which is common, that means you'll be left with only one x, because this x is actually is 2. S squared is 2, so you have 6x is out, so you'll be left with x here. Because this x is 2, you'll be left with x here. So s cos 2x. This 6x has gone out. Awesome. So you can leave your answer this way as well. Either this form or this form, you are still correct. So let's move straight to the second question. Applying the same method. So let's say solution 2. Solution 2. Applying the same method. So don't forget, like we have here, our y equals uv. So now select our u. Let u equals 2s cubed. And your v equals cos 3s. Awesome. Now, as usual, if your u, okay, let's bring our formula. As usual, our dy dx, because it's actually a product rule. So let's differentiate. Like we did in the first. So our du dx now, if you want to get du dx from here, as usual, our power will bring it back. Power here is 3, and you return what you have, and minus 1 from the power, and minus 1 from the power. Awesome. If you now say 3 times 2 here will give you what? Will give you 6. Minus 1 from the power 3 minus 1 will give you what? 2. Beautiful. So your du dx is what? 6x squared. You'll be able to iron out that. So let's get our dv dx from here. Because our v equals cos 3x. So to get our dv dx now, don't forget, if you are differentiating cos ax, it will give you what? Minus a sine ax. If you are differentiating cos ax, it will give you minus a sine ax. In the same vein, if you are differentiating cos 3x, it will give you what? Minus 3 sine 3x. It will give you what? Minus 3 sine 3x. That's one of the reasons I've taken my time to put that one down there. So if you are differentiating cos 3x, it will give you what? Minus 3 sine 3x. Beautiful. So let's apply our formula. We'll be able to get all our values. Beautiful. What's our u? Our u is what we have here, 2s cubed. What's our dv dx? This is our dv dx, minus 3 sine 3x. Minus 3 sine 3x. Beautiful. What's our v? This is our v, cos 3x. This is our v, cos 3x. So what's our du dx? This is our du dx, 6x squared. This is our du dx. Beautiful. So having done that, we've been able to insert all our value inside our formula. So all we just need to do is to open it up and see what we can do to it. Beautiful. So with this, if you say we want to open up this now, let's just multiply this number. 2 times 3 here will give us 6, definitely, but we have a negative sign here, so we just have our minus 6x cubed, since we are multiplying with this and sine 3x. It's as simple as that. So we just have our minus 6x cubed. That means we'll be able to iron out this and be able to open up the bracket. It's as easy as so. Just say this 2 times minus 3 will give us what? Minus 6. This s cubed, then sine 3x. So we move to this place. So 6x squared. Just multiplying this simply means you can now have 6x squared cos 3x. Square plus 3s. Beautiful. So open it up. So you can leave your answer like this, or if you look at it, maybe something is common. Okay, 6s square is common on both sides, so you can bring it out. S square is common, you can bring it out. And open up bracket. So CZ square has gone out. So you'll be left with a minus s, because if you open up this, you still have CZ key minus s and 3s. So this CZ square has gone out. You'll be left with what? Cos 3x. Beautiful. So you can leave your answer like this or like this. You can always pause, rewind the video for better clarification and understanding. If you have any issue with any of our video or this video, kindly drop a comment with us. We will appreciate it. We will reply as soon as we can. Help us like this video and subscribe to this YouTube channel, My Simple Maths. Don't forget to press the notification bell so that you can always receive notification from us whenever we post a new video.